Imagine looking up at the night sky and realizing we don't just admire those stars anymore. We actually harvest them. Our sun is no longer just this glowing orb up there. It's a power plant. It's a machine. And it is the ultimate turning point in human destiny. This is the staggering reality of stellar harvesting.
Think about this, and it's literally mind-bending. Our sun cranks out more energy in a tiny fraction of a single second than humanity has consumed in its entire existence, ever. Just let that sink in for a moment. Centuries of burning coal, splitting atoms, chasing sunlight, all of it is completely eclipsed by just a fraction of a second of our star's continuous fusion plasma.
So let's dive into part 1, the ultimate power plant, and how we're completely reimagining the sun.
Once you grasp the sheer, unbelievable scale of that energy gap, the rules of power and human ambition completely change forever. We aren't just talking about slapping slightly better solar panels on our roofs anymore, right? We're talking about scaling up in a massive way. And this isn't some science fiction pipe dream. It's a realistic step-by-step technological path. Step 1, we start with advanced, highly efficient solar satellites. Then, over time, that scales up into Step 2, where we build enormous swarms of orbital collectors forming these vast arrays in space. And eventually, this ambition snowballs into Step 3, massive stellar megastructures, orbital rings, and Dyson-like networks that gather a star's output for an entire civilization. It is the absolute ultimate expression of thinking bigger.
Which brings us to part 2, transforming human civilization and, essentially, the end of scarcity.
Let's bring this back down to Earth for a second. Because if we actually pull this off, what happens to our daily lives when energy isn't our biggest bottleneck anymore? Energy is the foundation of absolutely everything we do. The domino effect of benefits here is staggering. We're talking massive desalination that could generate clean water at scale for the entire planet. We could power global climate control systems. We'd have literally limitless AI infrastructure because our computational capacity would just explode. We'd even be looking at the viability of underground cities or entirely climate-stable precision agriculture. The energy cost of building and sustaining modern life drops so drastically that poverty as we know it could be fundamentally reduced.
Now, the crucial concept here is energy abundance. And look, this doesn't mean everything magically becomes free. Instead, it's a massive economic paradigm shift. When energy stops being scarce, the whole fundamental cost structure of civilization drops. Value moves away from raw power and floods into other domains, things like land, data, materials, expertise, and trust. You know, humans are never going to stop competing. We just end up competing over whatever resource matters most in this new era.
But of course, there's a flip side to this. Part 3, the new space race, looking at geopolitics and warfare.
This brings us to a much darker but totally critical question. If we can capture the energy of stars efficiently, who actually gets to control it? Is it a public asset? A private monopoly? As military strategists like to point out, the high ground is no longer a mountain, it is an orbit. That right there is a profound, game-changing shift in military strategy. Energy dominance has always shaped warfare. If one nation or one alliance can collect and store stellar energy better than anyone else, they gain an unbelievable advantage in propulsion, weapons, computing, and defense shields. The second we learn to harvest stars, the global struggle immediately shifts from where energy comes from to who gets to decide exactly how it's used.
So we're staring down a pretty clear crossroads here. In the best-case scenario, Earth actually heals. Heavy polluting industries move off-world, and we see real planetary unity and reduced conflict, simply because the shared, monumental challenge of building this infrastructure basically forces humanity to collaborate on an unprecedented scale. But, in the worst-case scenario, space becomes this crowded, super dangerous minefield of orbital waste. We'd see cosmic-level inequality and a terrifying new arms race over orbital real estate and collector swarms.
Okay, let's get into the mechanics of this in Part 4, Engineering the Impossible and Surviving the Star.
Because to even have a shot at that utopian best-case scenario, we have to overcome some immense, incredibly hostile physical challenges. We are talking about building autonomous machines right next to a giant, angry sphere of continuous fusion plasma. To put that into perspective, compare repairing a downed power line here on Earth, which is, localized headache, with maintaining a civilization-level energy system in the middle of deep space radiation. It's a completely different reality. If you drop a wrench out there, it's a civilization-level problem. Any failure in that stellar environment could be absolutely catastrophic.
So to keep a megastructure like this from failing, we'd need an entirely new tier of technology.
We're talking autonomous repair systems that operate 24/7 without any human intervention. We need extreme radiation shielding and durable materials that can somehow survive impossible temperatures. You'd need massive, coordinated robotics fleets and insanely advanced artificial intelligence just to manage the architectural logistics across vast timescales.
Which leads us directly to this absolute rule of thumb. No civilization can safely depend on a cosmic-scale machine unless it has planned for failure at literally every single level. You can't just cross your fingers and hope for the best in deep space. A system capturing the power of a star has to be able to survive losing part of itself. That means distributed architecture, extreme redundancy, backup systems, and rock-solid emergency protocols. Those aren't just nice-to-haves, they are literally the only things keeping the lights on.
Let's zoom out even further for Part 5, the interstellar expansion, looking way beyond our sun.
Because think about it, if we successfully harvest our own star, the next logical step, the burning question, is whether we can do it to many stars. The trajectory builds so naturally. Era 1 is all about harnessing our own sun. That unlocks Era 2, which is establishing habitable orbital networks and off-world industry, and that acts as a giant springboard for Era 3, actual interstellar transport, giant data webs, and long-term civilization far beyond Earth. The stars literally become a web of life-supporting engines, propelling human expansion deep into space. Expansion itself becomes astrophysical.
But seriously, how do you even govern that? Do traditional planetary governments still rule, or do interplanetary organizations and artificial intelligence have to coordinate these systems? Because a society that spans multiple stars absolutely cannot think in terms of traditional borders or countries anymore. It has to think in terms of star-scale logistics. Our forms of governance must physically evolve to manage this immense power responsibly. Maybe humans focus on the big picture, strategy, values, adaptation, while AI handles all the complex, granular technical operations.
This triggers a massive societal shift. Part 6, a cultural revolution, focusing on mind and meaning.
Beyond all the engineering and the astrophysics, how does everyday life, our mindset, and our very culture fundamentally transform? Well, right out of the gate, the whole concept of education and a career completely shifts. Kids aren't just going to learn basic physics, they'll be studying orbital economies, habitat governance, space law, and civilization-scale sustainability. The idea of going to work will be intrinsically tied to maintaining a living, breathing system that spans planets, moons, and stars.
Psychologically, this is huge. The night sky literally changes from a symbol of this unreachable, vast distance to the literal infrastructure of human survival. Artists, writers, humanity at large, we will completely reimagine the cosmos. We won't just look up in awe of the unknown anymore. We'll be looking up at our civilization's power grid. The stars become things we engineer around, live near, and completely depend on.
So at the end of the day, it all boils down to this. What kind of civilization do we become once we learn how to touch the stars? If scarcity finally loosens its grip, we're freed up to focus on exploration, creativity, and our long-term survival. But abundance also tests our wisdom. It can drive incredible exploration, sure, but it can also breed dangerous complacency. Do we actually have the discipline to wield that kind of power without becoming careless? Because harnessing the power of the stars isn't really the final question. The final question is who we choose to be once we have the power to actually reach them.